Wow, it seems like every day there's a new development in large language models.
Yeah, it's really moving fast.
I mean, look at DeepSeek making headlines with their R1 model.
Nice.
Trained for only $5.6 million.
That's amazing.
That's really got everyone talking about open weight models.
For sure.
And speaking of open weights, we've got another player stepping in, Alibaba, with their newest release, Qwen2.
Yeah, and what's really interesting is they're going head-to-head with companies like DeepSeek and even Meta by fully embracing open source.
Oh, really?
Yeah, they're releasing the model weights for Qwen2, so researchers and developers can use it freely, adapt it, do whatever they want.
So it's a totally different approach compared to companies like OpenAI and their GPT series.
Exactly, much more open.
It seems like there's this growing movement toward open weight LLMs, and it'll be interesting to see how that shapes the AI landscape.
Yeah, for sure.
But let's get down to the details. We're diving into the Qwen2 technical report today, taking a look at the model architecture, training process, and some key evaluations.
Sounds good.
I see they stuck with the same byte-level byte pair encoding tokenizer from previous Qwen models.
Yeah, that makes sense for a few reasons. It's efficient, especially for handling multiple languages.
So that's part of why they did it.
Exactly. It's a recurring theme with Qwen2. They're really focused on building a model that can work across different languages.
Multilingual capabilities,
Uh-huh.
ground up.
Yeah.
I like it. But the model architecture itself has some new tricks. They switched to grouped query attention this time around, GQA.
Uh-huh.
What was the motivation behind that?
Well, it's all about efficiency, especially during inference.
Okay.
When you're using an LLM in real-time applications, speed is key.
Right.
GQA optimizes how the model uses its memory cache, and that results in faster performance.
So they're making sure Qwen2 can keep up with the demands of real-world use, even on devices with limited processing.
Exactly, yeah. It's particularly useful for folks who might not have access to massive computing resources. Makes it more democratic, you know?
Democratizing access.
To these powerful AI tools.
I like it. Now, I'm also seeing something about dual chunk attention, DCA and Yarn.
Yeah,
These seem to be all about pushing the boundaries of context length.
you got it. DCA and Yarn work together, extending Qwen2's context window up to 131,072 tokens.
Wow, that's a lot.
Yeah, processing whole books, research papers, code bases, all in one go.
That's insane. I can already see the potential applications for research and development. Okay, next up, we've got the mixture of experts, or MOE model.
Right.
I'm always intrigued by this approach.
Qwen2 includes a MOE model alongside its dense counterparts, and they've made some interesting design choices.
Like what?
Well, they're using fine-grained experts, which are essentially smaller, more specialized models within the larger MOE framework.
So instead of having one massive model trying to do everything, they've got a team of specialists, each with their own area of expertise.
Exactly. It's a good analogy.
But how do they keep all these experts organized and efficient?
That's where the concept of shared and routing specific experts comes in. Some experts are shared across various tasks, kind of providing a foundation of general knowledge. Then there are routing specific experts that are activated only when their expertise is needed.
So balancing breadth and depth of knowledge, making sure the model is both comprehensive and efficient.
Right, that's the goal.
Clever.
Yeah.
I'm also seeing terms like expert upcycling and diversified initialization.
Yeah.
What's going on there?
Those techniques are about optimizing performance without needing excessive computational resources.
Okay.
Expert upcycling reuses and adapts weights from a dense model to initialize the MOE model, giving those specialists a head start in their training. Diversified initialization makes sure that each expert has unique characteristics.
So they're not just throwing a bunch of experts together, they're carefully setting them up for success.
Exactly.
It seems like a lot of thought went into making this MOE model as powerful and efficient as possible.
Definitely. They've also made sure there's a Qwen2 model for everyone by providing a range of model sizes, from a compact 0.5 billion parameters up to a massive 72 billion.
That's great for accessibility, whether you're working with limited resources or you have access. Okay, moving on to long context training. How did they train Qwen2 to handle those massive input sequences?
They increased the context length during training gradually, eventually hitting 32,768 tokens.
Okay.
They also incorporated longer data sequences into the training process, and they modified rotary positional embeddings, or ROPE, to better handle length extrapolation.
So they're not just throwing a bunch of long text at the model and hoping for the best. They're strategically adjusting the training process to accommodate those longer sequences.
Yeah, exactly.
That makes sense. So are they seeing any positive results?
Oh, yeah. Preliminary experiments show minimal perplexity degradation, even at 131,072 tokens.
Wow.
So it suggests Qwen2 can really handle those super long contexts.
That's great. Now that they've got this powerful pre-trained model that can handle tons of information, what happens next?
Well, that's where the post-training phase comes in.
Okay.
They refine Qwen2 for specific skills and align it with human preferences.
The alignment process, very important. What approach did they take with Qwen2?
They focused on scalable alignment with minimal human annotation.
Oh.
They use both human-annotated data and automated methods to create the training data for supervised fine-tuning and reinforcement learning from human feedback.
I'm almost fascinated by those automated methods. What specific strategies did they use for, synthesizing data?
Well, for things like mathematics, where there's a clear right answer, they used rejection sampling. The model generates a bunch of solutions, and only the correct ones are kept for training.
Interesting. So they're leveraging the model's own capabilities to generate training data, almost like a self-guided learning process.
Exactly. And for coding, they actually run and test the model's code to see if it's correct, providing real-world feedback.
So it's not just theoretical knowledge, they're really putting those skills to the test. What about tasks like literary writing or safety alignment?
For literary tasks, they repurpose public domain works, giving the model instructions and using those original works as a guide. And for safety and value alignment, they used what's called constitutional feedback.
What's that?
It's basically setting a bunch of principles for the model to follow, rewarding it for generating responses that adhere to those principles.
So they're setting up guardrails, some guidelines to help the model learn to behave responsibly.
Exactly.
Now, let's talk about the supervised fine-tuning itself.
Okay.
What can you tell us about the instruction dataset they used and how they fine-tuned the model?
They had a huge instruction dataset, over 500,000 examples, and they covered a wide range of skills. They fine-tuned the model for 2 epochs, with a sequence length of 32,768 tokens, and carefully adjusted parameters like learning rate and weight decay.
So a robust dataset and a very controlled fine-tuning process. Now, how did Qwen2 actually perform?
This is where it gets interesting. They took a multifaceted approach to evaluation, using established benchmarks and human preference assessments to see how both the base and instruction-tuned models performed.
Okay, let's break down these evaluations. What were some of the key benchmarks they used, and what did those results tell us?
They evaluated Qwen2 on a ton of different tasks. For language understanding and knowledge, they used benchmarks like MMLU, which stands for Massive Multitask Language Understanding, to see how well it understood the world.
Okay.
They also included benchmarks like MMLU Pro, a tougher version of MMLU, and GPQA, which tests scientific question answering.
So really probing its ability to handle complex information. And how did Qwen2 do?
Qwen2, especially the larger models like Qwen2.5-Turbo, did incredibly well. They beat a lot of previous open weight models and even did as well as some of the top proprietary models.
Wow, that's a big deal for an open weight model. It shows the training data and methods were really effective.
Yeah, absolutely.
So open weight models are catching up and maybe even surpassing their proprietary rivals.
Mhm.
This could change things for AI research and development.
For sure.
Now, what about coding? What benchmarks did they use to evaluate Qwen2's coding skills?
They use several, all designed to test different parts of coding. Human Eval, for example, assesses how well the model can generate correct working code from just natural language descriptions.
So it's like giving it a coding assignment and seeing if it passes.
Exactly. They also use MBPP, which focuses on solving programming puzzles that require logical thinking and problem solving.
That's the stuff that separates the real coders from the beginners.
Wrong.
How did Qwen2 perform on these benchmarks?
Qwen2 did exceptionally well, showing it really gets programming concepts, syntax, and best practices.
That's good to hear. Did they test it on any real-world scenarios?
Yeah, they even evaluated it on a new benchmark called Live Code Bench. It tests how well the model can generate code that actually works in the real world.
So handling edge cases and unexpected input, the kind of stuff you need for a real application.
Exactly, and Qwen2 proved it could handle that.
Now, on to mathematics. What benchmarks did they use to see how good Qwen2 was at mathematical reasoning?
They used GSM-8K, which tests if the model can solve math word problems. Those problems need not just math knowledge, but also understanding language, picking out the right info, and using the right math operations.
It's like a test of how well it can think mathematically.
Yeah, and they also use math, a harder benchmark with a wider range of problems, from algebra and calculus to statistics and probability.
So they really put it through its paces.
They did. And Qwen2, especially the larger models, did very well again. It got state-of-the-art results on some of these tests.
Wow.
This shows how good it is at abstract reasoning and problem solving, skills that are useful not just in math, but in many other areas.
It's fascinating to see how these models are getting so much better at different kinds of reasoning.
Yeah.
Now, you mentioned human preference assessments in addition to these benchmarks. Can you tell me more about that part of the evaluation?
Yeah, benchmarks are great for measuring performance, but they don't capture everything about language and communication. For that, you need humans.
Makes sense.
They had expert annotators rate Qwen2's responses on various tasks, comparing them to responses from other LLMs, both open weight and proprietary.
So they had humans judge things like fluency, coherence, creativity, and safety. Those things that are hard to measure with just numbers.
Exactly. And the results were good. Qwen2 consistently got high marks for fluency, coherence, and overall quality.
So it can generate text that's both engaging and informative, which is really important for things like chatbots and virtual assistants.
Yeah, you want them to feel natural and engaging, not like robots.
Right. And did they find anything about safety?
They also found that Qwen2 was less likely to generate bad or offensive content compared to some other models.
That's good to hear. Now, I'm really curious about Qwen2's multilingual capabilities. We talk about how they included a lot of multilingual data in the training, but how did they actually assess its performance in different languages?
They went above and beyond typical benchmarks and had humans evaluated in lots of languages.
Wow, like what?
Chinese, Spanish, French, German, you name it.
So they got native speakers to see how well Qwen2 could translate, answer questions, summarize, and even write creatively.
Exactly. They wanted to get a real sense of its strengths and weaknesses in different languages.
And what were the main findings? Did Qwen2 live up to the hype?
Qwen2, especially the larger instruction-tuned models, showed amazing fluency and accuracy across many languages. It even beat GPT 3.5 sometimes.
That's impressive. It really seems like they've made great progress in building a truly multilingual model.
Definitely. This could change how we communicate globally and understand each other across cultures.
That's a powerful idea, but we can't forget about safety and responsibility. How do they evaluate Qwen2 in those areas?
They know how important it is to develop these models responsibly, especially since anyone can use them.
Right.
They did a big multilingual safety evaluation focusing on sensitive areas like illegal behavior, fraud, pornography, and privacy. They wanted to make sure Qwen2 wouldn't be easy to misuse.
That makes sense. So how did Qwen2 handle those tricky topics?
Qwen2.5-B instructed pretty well, rejecting more risky prompts than other models, even GPT-4.
Okay, that's encouraging. But they're not claiming to have solved the safety issue entirely, are they?
No, they know there's always room for improvement, particularly in areas like filtering content.
It's good to hear they're taking it seriously and making progress.
Definitely. Building safe and responsible AI is an ongoing process.
Absolutely.